Hello students, welcome to Sops's classes. Today we'll be solving the CSIR UGCNET JRF exam questions from the June 2015 paper. We'll be solving the linear algebra questions today. The question that we'll be solving today came for 4.75 marks in the exam. So let's start off with the question. The question is that an n cross n complex matrix satisfies a to the power k is equal to in, where k is greater than 1 and is a positive integer. Now if 1 is not an eigenvalue of a, then which is true? Option A is diagonalizable. Option B, a to the power k minus 1 plus a to the power k minus 2, and it goes on up till a that the summation is equal to 0. Option C is trace of a to the power k minus 1 plus trace of a to the power k minus 2 plus it goes on up till trace of a is equal to minus of n. Option D is a to the power minus k minus 1 plus a to the power minus of whole k minus 2, and it goes on up till a inverse that is equal to minus of I. So now if we write down, now here minimal polynomial, a minimal polynomial has distinct linear roots, or we can write as factors. So this implies that option A is correct. Similarly, A satisfies x to the power k minus 1, which is equal to x minus 1 into x to the power k minus 1 plus x to the power k minus 2, and it goes all up till x plus 1 is equal to 0. But 1 is not an eigenvalue of a. So this implies that a minus basically if we put lambda over here, basically this will not be equal to 0. X minus 1 is not equal to 0 for a. So that implies that a satisfies this part of the equation, and we can write a to the power k minus 1 plus a to the power k minus 2, and it will go on plus a plus I is equal to 0. So this implies that if this is equal to 0, then this implies that a to the power k minus 1 plus a to the power k minus 2, and it will go on plus a is equal to minus of y, which is not equal to 0. So the option B, which says that this part is equal to 0, is not correct. So therefore we can write that option B is false. Now let's move on to the next option. So as you can see that the matrix a to the power k minus 1 plus a to the power k minus 2 plus it goes all up till a is equal to minus of I. So therefore we can write that trace of, if we find out the trace of the matrix, is k minus 1 plus trace of a to the power k minus 2, and it goes all up till trace of a. So this will be equal to n into minus 1, which will be equal to minus of n. So this is equal to, since all the terms are minus 1, when we add it up, this is equal to minus 1. So we can say that option C, therefore option C is the correct option. Now let's move on to the option D. Now we know that we have already found out that a to the power k plus k minus 1 plus k minus 2 up till a plus I is equal to 0. So this implies, from this we get that a is invertible. Now if a is invertible, this means the determinant of the matrix A is not equal to 0, and that implies that 0 is not an eigenvalue of A. So if 0 is not an eigenvalue of A, so that implies that we can multiply both sides of this equation by A inverse. If we multiply not only A inverse, we can multiply this by A to the power k minus 1 both sides. So if we multiply both sides by A to the power multiplying, so which statement will multiply? We'll multiply A to the power k minus 1 to both sides of A to the power k minus 1 plus A to the power k minus 2, and it will go on plus A plus I equal to 0. We'll multiply this and we get A to the power minus k minus 1 plus A to the power minus k minus 2, and this will go on plus A to the power A inverse will be equal to minus of I. So this is what we'll get. So if this is what we're getting, then we can definitely write that option D is also correct. So we can write that correct option are A, C and D. So today we have solved a linear algebra question which came in the June 2015 paper of CSIR UGCNET JRF exam paper. We'll be solving the next questions in the subsequent videos. Till then, keep watching Soft Classes videos for more solutions and content. Thank you very much.